Hi everybody, welcome back. Thank you for joining us. Welcome if this is your first time, welcome back. If you've been at previous webinars in this series, and of course welcome if you were with us just over a week ago when we had the first attempt at this webinar. I'm very delighted that Tianzhen has found time in his busy schedule to accommodate us for this second attempt at occupant-centric performance metrics and performance targets, because it is such an important topic. We spend a lot of time thinking in the building simulation world about designing buildings from an energy perspective, thinking about space standards and so on, but actually putting occupants at the heart of what we do is surprisingly rare. So this is a really important session. And so in a minute, I'm going to invite Tianzhen to share his screen and to give his presentation. But before that, I'll just tell you a little bit about how things are going to be run during this session and where you can find out some more information. So after Tianzhen has finished his presentation, we will have questions and answers, and we should have around 15 minutes for that. If you have any questions that come up during the course of the presentation or that you think of while you're listening to answers to others, then do use the Q&A box, which should be at the bottom of your screen, to pop your questions in there, and I will put them to Tianzhen after his presentation. So this webinar, like all of the IBIPSA webinars, is a core part of the IBIPSA Education Committee's purpose. So the committee exists to identify education and training needs throughout the building simulation performance community. That's not just academia, that's the private sector and government as well. And we aim to initiate and develop new education materials and methods. And really importantly, part of our mission is that the training sessions that we offer, like this one, are open to non-members as well as to members. And the sessions that we run are all recorded, and you can see them afterwards on our YouTube channel, and I'll tell you a little bit more about that at the end of this session, and I'll tell you also about some of the other presentations that are coming up. So this is now the midpoint of our series on occupant-centric simulation-aided building design. So Tianzhen, I'm delighted to have you here. If you could share your screen and we can get started, that would be great.
Okay. Yeah. Thanks, Pamela. Let me try to share my screen with my slides. Okay, you see my screen?
I do. That's perfect. Thank you.
Okay, wonderful. Yeah, so thanks, Pamela, and good morning, good afternoon, or good evening, depends on where you're calling in. And thanks for dialing back. We have a little, technical issues last one. But I'm Tianzhen Hong. I'm a senior scientist with the Lawrence Berkley Lab, and I appreciate the opportunity that IBIPSA Education Committee, offers to the authors of this book. And I think some of you already attended, right, the previous seminars talking about, how to understand occupants' needs and gather those data, to guide the building design operation. So today I'm going to present chapter 5 of the book, and it's called Occupant-centric Performance Metrics and Targets. So this is the book, and it's open access. So there's a DOI link there. Feel free to go to that website and read a PDF and download a PDF, share in ways that you would like to. But the book has a total of 12 chapters. There's an introduction about why we about 30 people wrote a book, and Liam and Farhan are the two co-editors, guiding these 30 co-authors for almost 2 or 2.5 years. So there's a lot of effort put into the book, and so there are 4 chapters of fundamentals in the book. As you read from the screen, there's a chapter about fundamentals of indoor environmental quality and occupant needs. There's a chapter about, occupant in a building design, decision-making process, a chapter about how to obtain those occupant perspectives. And I'm going to talk about chapter 5. These are occupant performance metrics and performance targets. So on the right, there's also 5 chapters more focused on simulation approaches and how to apply those techniques in a building design process. So ensure we design a building not just energy efficient, but also occupant, comfortable, and that ensure their health and productivity. So very important, there's a chapter dedicated to case studies, and those are the very nice examples, illustrates the previous chapters and how those techniques apply in the real building projects. So I think those are real world examples, and definitely worth taking a close look. So so this is the book, and I think just talking to Pamela, looks like next Monday, Liam is going to present chapter 6, fundamentals of the occupant modeling, and Adisha will present the fit for purpose modeling, the week after. So those are the 2 chapters that dive deep into, occupant modeling technique. And I think some of you may read some literatures. There's a lot of advances, in occupant modeling and simulation for the last, 10 years. And actually, much more data becomes available, tools become available. So I think it's ready, right? Thinking about how to apply those kind of tools in actual building design, projects. So chapter 5, we have like 5 sections. There's an introduction, but then we dive into the performance metric, asking the question about why we need occupant-centric, performance metrics. And what are those metrics? What do they represent? Different aspects of building performance. And then we ask ourselves, well, then what kind of methods, right, we can use to quantify the occupant metric? And then next is, once we understand those previous questions, then we get to a very practical question about how can we set the occupant targets, and what are the bases, and what do they, imply? And then there's a, summary leading to some future thinking or further readings. So we have 5 co-authors of the chapter. I'm leading the chapter by Liam and my colleague Han Li, Jacob from Germany, Carrie is from UK. There's also Joe Tanegi from University of Texas and Austin. So we work nicely, as a team on this chapter. So just try to summarize the background, and as you see, figure on the left illustrates smart, agreed interactive, efficient buildings. So buildings energy demand becomes much more dynamic. As you see the illustration, right? The building may have on-site energy production from PV, there may energy storage, there may be EV charging, and there's a lot of sensing, to ensure that we use energy wisely during the time when people are in a space. And of course, this is in addition to, the post-pandemic, right? We still have some flexible, working mode. So not necessarily everybody will be in the building, right, at the same time. So the occupancy becomes much more dynamic. So I think that is quite different from the pre-pandemic. And on figure on the right, basically it shows California state's net electricity demand on the power grid. And this is on the lowest, demand day, usually in the, late March to early April. And as you can see, the curve, there's sometimes we call it a dark curve, right? So the net demand on the power grid during the middle of the day is getting pushed down further and further, right? With, much more PV and, wind turbine, deployment in California. So basically, right, we care about, not just the total energy consumption. We now care about when that energy use occurred. So that is also a very important change, because the pricing, right, during the peak demand, which is now moving to, between 4 p.m. to 9 p.m., is going to be much more higher than the consumption of, 1 equal amount of electricity during the middle of the day. So I think these are the two important factors to consider when we try to evaluate a building's, performance. Occupancy is much more dynamic these days. The energy cost or the associated carbon footprint is also changing, depends on when, right, you use the, electricity. So with that in mind, then we ask the question, then how can we understand, a building's performance? Is it good, and good compared with who are the peers? And so here at LBNL, we developed this building performance database, for the U.S. Department of Energy, and the database basically has more than 1 million buildings and real energy consumption data. So basically, you can, compare your building's energy consumption, and this can be site energy use or source energy use, right? Compare with the peer group, at different, same location, same climate, or different location. So they give you idea, at a very high level, but this is using the metrics. Sometimes we call it EUI, energy use intensity. So basically, it's a kilowatt hour per square meter for the whole year. And as you see, that it's using the building's total floor area as the denominator to represent the service level. And earlier I mentioned that does not represent, right, the energy dynamics across the day, and does not represent the dynamic occupancies we see right these days in residential or commercial buildings. So in this chapter, we use the term metrics, loosely to represent different aspects of building performance, and that include energy use, their associated, greenhouse gas emission, indoor environmental quality, water consumption, solid waste, safety, mobility, survivability. So these are all the, dimensions of building performance, that get considered in the building design and operation. So for the KPI, then basically we go one step further, right? We want to make sure these are the key performance indicators, right? Build upon the metrics, basically represents, right, the resource consumption divided by the, the service, provided. And the UI, that's a very static, right, KPI, kilowatt hour per square meter per year. But there's also other KPIs like representing the peak electricity demand, like watt per square meter. But there's other KPI represent the services like set-point temperature unmet, unmet hours, and many of you running simulation, you usually use these to do a very high level check whether your simulation makes sense, like all the equipment, right, auto sizing, does it meet the loads, in all the different spaces. And we also care about some of the temperature related, thermal comfort issues. So there's also indicators that represent those. And so the hierarchy is basically looking at, all the data from the built environment, like a sensor meter, those are the raw data, but you also have sensing of the indoor environmental conditions, like the temperature, humidity, CO2. So at the end, those get, right, used to calculate the indicators, for different type of, KPIs that later we can use to help us understand, how a building actually performs. So theoretically, right, if we think, right, for example, residential building, office buildings, right, represents the services that occupant needs, then we would like to see, a theoretical correlation between the occupancy level and the building's, power demand, as the figure on the right illustrates. So basically, right, there will be a certain minimal occupancy level, then your building's energy consumption start to stabilize, right, getting to the minimum. It would not go to zero because you still have some emergency lighting, some of the equipments that run 24/7, but that's the minimum. But with the occupancy increase, you would like to see there's a more sort of linear correlation, right, with the energy demand increase, until it gets to maybe 70, 80, or 90%, then the power demand gets to the maximum. So that's the theoretical way, if we think about, right, we have all the technology to do that. But in reality, I think there's a lot of data from the COVID-19 pandemic shows, right? A lot of the buildings, almost empty, or very low occupancy level, but they still, use a lot of energy. So I think that's a big question. We are asking, can we better design? Can we better operate? What are the key issues that we don't, see the positive correlation between those occupancy level and energy consumption. So that triggers the thinking about we should have different type of metrics that can better represent the occupant dimension, in the building's total performance. So we all understand that right, occupants have different ways of interacting with the building's component and systems. For example, you may have operable windows, right? You open windows maybe for fresh air, maybe when outdoors cooler than indoors, and you close it maybe, because outdoors noisy and, for different reasons. You dim the lights, you may have enough lights from the daylight, So you may dim it for reduced glare or different kind of reasons. And the thermostat, right? If you have access to and you can control it, right? You adjust it just to so that you feel comfortable, not too cold, not too warm, right? And most people now have multiple monitors, and so when you are leaving the space or go to a meeting, so you may turn the monitors off. And of course, right, most of those technology also now have the standby mode. Means they will turn it off, after a few minutes, if there's no use of the of the monitor. And we have more the different smart devices, IoT sensors, and that you can interact. For example, those kind of very handy app gives you the possibility to provide feedback. Am I feeling too hot, too warm? And that would nice feedback to the building operators so they can adjust the HVAC system operation to meet your needs. So there's all these different ways, and obviously these would influence people's behavior as well. So we sort of design this framework to represent occupant-centric metrics. At a higher level, this is the resource consumption and environmental impact. So thinking about, right, from a building's perspective, right, what is the total energy used for the whole year? But if we represent on the occupants basis, then we are asking, it's the kilowatt hour per person per year, or the kilowatt hour per person occupied hours. So those are different, denominators basically try to represent the services that directly, related to the, to the occupants. The peak demand, similar way, but it's looking at, of course, right, the maximum demand, the related GHG emission, water use, space use, the occupancy hours, which is also a very important indicator for the services, right, provided to occupants. And sometimes we try to understand, the ratios between the occupied and unoccupied hours, as earlier illustrated, right? In a theoretical building, we should see a building consume much more energy during occupied hours than unoccupied hours. But in the reality, the ratio, can vary in a wide range, and that usually gives an indication of some building may have potentials to improve energy efficiency. The second dimension of this is about the services provided to occupants. We're talking about comfort, indoor air quality, and some other type of services like, survivability. So if a building during very hot summer day, but the power is off, then basically we care about the bottom line, whether people can survive in those extreme temperature environment, for extended hours. The last one, very important, is the human-building interaction. As we just mentioned, I think the designer building need to think about the flexibility, giving occupants to assess and adjust, the building's components and technologies. That can be operable windows, thermostat, movable shade, dimmable lights, and some personal equipment like a portable fan, portable heaters. Of course, there's always some safety concerns about those kind of personal devices to avoid fire hazard. And there's also debate about the control. Should it be manual? Should it be fully automatic? Should it be hybrid? And central control and personalized or local control is also a debate. How to give people basically the flexibility, but also be able to consider the diverse occupant need, especially in those shared open spaces. Last one, occupant feedback, via through those different ways, either app or some surveys, some dashboard. I think that's very important to, engage occupant in a more proactive way so that they know their behavior actually will influence the building's performance. I think that's very important to close the loop, when you talk about occupant feedback. So when we look at the key influencing factors or features of the occupant-centric metric, I think this just illustrates that the metric would obviously relate to spatial and temporal dimensions of the performance we are talking about. And so, for example, the performance factors, then we care about energy-related, IEQ stuff and associated, the GHG emissions, right? And sometimes we need to compare, across space, compare across building, compare building across climate. So we also need to consider what are the normalization factors, like occupancy, like level, like climate, and how we quantify these. So that's broadly later I'll talk about, through some measurement or through some building performance simulation to give us the way to calculate those occupant-centric, KPIs. And those KPIs sometimes, are single value, like average consumption or the peak demand, but sometimes it's a time series value, like 24-hour profiles to represent load shape, so it's not necessarily always a single value. It can be monthly value or it can be a profile. So key attributes we would like to see for a good KPI would include, for example, easy to understand, whatever KPI we try to use, right? And that means, understand by not just the researchers, but also by the designers and practitioners, right? And understand, what goes to the nominator and the denominator. And what are the potential sources of data that we need to collect in order to calculate those KPI. So that's be able to quantify the KPIs. It's a necessary requirement. And very important is also try to understand, well, KPIs serve certain purposes. So if we have a KPI in a certain range, or it exists the upper range. And so what does it imply, right? For example, one of the KPI, I think we mentioned, if the energy consumption, during unoccupied hours is relatively high, then we probably need to think about, why, right? Maybe there's a lot of equipment get left on during the nighttime, during the, unoccupied hours. So those should, have clear implications of what potential actions that the stakeholders or the building operator or managers, be able to think about and follow through. We talk about how to make sure the KPI are normalized in a way so that we can compare it across different scales, different building, different climate. So I think that's important if those KPI want to be used for benchmarking, purposes. The last one, also very important, is make sure the KPIs are fair and objective. And I think an example given, in the book is how we normalize it. And, we know sometimes we normalize by the design occupant level, right? But that is a single static number. And we all understand actual occupants will vary, right? Hour from hour, day from day. So, how do we really think the normalization I think it depends on how we use that KPI, for what purposes, buildings and life cycle processes. So now I'm going to talk about different approaches, how we quantify the occupant-centric performance metrics. And I think the first approach is performance measurement, right? So I think now it's low-cost sensors and meters that actually, can do a good job in terms of collecting data we need, for use in the calculation of the occupant-centric KPIs. And the table just shows these are the typical, data we collect, from the sensors, meters, or devices. For example, occupancy. So you can count the occupants, or we call occupancy status. Depends on what kind of sensors you have, and that kind of measurement, of course, will vary. You do it at a space, or you do it at a whole building. Like when you enter the building, you may need to swipe your car. So that's also the whole building level. Those kind of information are much more easier to get than doing at a space level. But of course, at a space level, that gives you a granular information that may be later used to inform occupants effective usage. The IEQ parameters, and as you see from the table, so these are the common parameters that get collected, temperature, humidity, CO2 concentration, and there's also illuminance levels, acoustic levels, and it all depends on what are the major concerns or metrics that you are looking for. Resource consumption, so these are the energy use, electricity, natural gas, water use, and so all different resources. Environmental impact, and these are basically the associated carbon emissions, solid waste, associated all the services provided to occupants. And the last one, as we mentioned, the human building interaction. So I think this is very important, and usually we don't pay much attention to this, but I think this becomes important as we are pushing to the the zero net energy buildings. I think the occupants have a growing role in terms of ensuring those kind of low energy buildings are actually operating as to meet the design intent and achieve their energy goal. So this is an example provided by Jacob Han, and it's a 8-unit high efficiency residential building in Germany. And so they have done this post-occupancy evaluation for multiple years, from 2013 to 2016, and basically try to understand, whether the building's operational performance, meet the energy certificates, and also, interesting in figuring out how the performance will vary, year by year. So the figure on the left, this just shows the, space heating, and this is from the district heating system that serves the entire multifamily building, but it's 8 apartment units. So if we use the metric, like kilowatt-hour per square meter, per year, basically you can see, for example, the unit 1, the unit 1 has quite higher consumption, heating energy consumption. But if we normalize by kilowatt hour per person per year, then the highest is actually not apartment 1, it actually is apartment 5, that has the higher consumption. So basically, this tells you when we use different metrics, you may see the performance, different, and I think depends on the goal or the certificate. You may need to consider both metrics in order to do a fair, evaluation or benchmarking. So the figure on the right basically shows the total electricity consumption, and these are basically for lighting, appliances, and maybe some cooling. And I think, again, it shows that if we use by the building floor area or use the number of occupants, you will see, different, metrics and, different performance, different levels of performance, across these 8 apartment units. So just keep this in mind, and these are a nice example using the real measurement data, to show how the, differences of metrics can inform, right, different aspects of the building performance. There's also a conference paper. So if you're interested in reading more, I think the, Hans conference paper will provide, more detailed information about this particular study. Okay, so we'll move a little bit quickly. So obviously the second method, right, to quantify occupant-centric metric would be, right, through a building performance simulation. And, as I mentioned earlier, for the last 10 years, there's a lot of advances that have been made in the occupant modeling techniques and data sets. So the table just shows, right, there's all different kinds of models, tools developed to simulate occupancy in a building, right, to understand, when or why a window is open, by certain group of occupants, lighting, dimming, thermostat adjustment, so those models get developed, and you can definitely, right, incorporate them in the traditional building performance simulation. So the figure on the right basically shows sort of a workflow. So usually, right, you run the occupant modeling tools to provide better assumptions and data, then that goes to the traditional building performance simulation. And at the end, you do some sort of post-processing in order to calculate those occupant-centric, KPIs, right? And depends on your goal. Sometimes you do this kind of simulation in the code simulation mode. And so, but it's a different ways, right? You can do it. So I just want to mention a tool we developed here at LBNL, and it's open source code. It's part of the, Open Studio ecosystem. So some of you, right, may have used Open Studio, but basically it's a wrapper. It's a middleware that wraps around the simulation engine Energy Plus, so gives you a better way to, prepare input for Energy Plus, be able to change Energy Plus model. And so we developed these measure, basically to help you ensure you have the right output variables, incorporated in Energy Plus model, and then it takes the output from Energy Plus simulation and then do the post processing to calculate, those KPI. There's also nice visualization of the KPIs in like a web, HTML, page. So yeah, feel free to look at the link and, give it a try and provide us feedback. So this is probably the last topic I'm going to cover for this chapter. So we talk about performance metric, we talk about methods to calculate the metrics. Now there's a question, about, well, how can we set, what different thresholds or levels of those KPI and what are the bases? So there are two approaches, and this section was written by Liam. And so basically it's a top-down approach. So if you think about, right, those KPIs, for the real building, basically has a distribution, right? So it's the figure on the left illustrates. So basically you try to set a target, am I going to be on the top 10%? So then you cut these, vertical lines, and this is an example like a kilowatt hour per occupant hour, So this is the top-down approach. And you need to basically get a nice representation of this distribution, for the buildings that you are interested in. The other approach is more like the bottom up, and this is more in a design process. You try to set a quota, like the space used, is it 10 square meter per occupant? What's the occupant density, basically? For example, the parking space needs, right? The water consumptions, the lighting, the illuminance needs. So these are sort of more from the bottom up. Then you set a quota of the different end uses or function or services of the buildings. And then you can aggregate, then try to calculate those occupant KPIs. I think depends on your needs and in your team, right? You may choose one or the other, or you may choose a combination of two. So how you use those performance target to guide the building's design process, and this table just illustrates, the potential ways you can do it. So, for example, the typical available information, right? We talk about there's a conventional metric, there's a occupant-centric metrics, and then with this, there's an early design, there's a schematic design, there's a detailed design, there's an occupancy. Those are different stages of the building life cycle, right? So at a programming design briefing, then you basically, right, would have some plan occupancy levels, right? Space uses, office, and all those conference rooms, and you would have some estimate like floor area, right? So I think again, that's slide mentioned, right? You may have estimate those space needs, right, based on the occupancy levels, right? And another example is the detailed design stage, right? So the conventional metric, you look at the total energy use. We look at a kilowatt hour per square meter per year, but then you may have breakdown into lighting, plug loads, and HVAC related, end uses, right? And you may use the met hours, to represent the services provided to the, to the occupants. But with the occupant-centric metrics, I think we can do a better job because we can look at those energy use in terms of occupant hour, and that may be a fair or more normalized metrics, to compare your design alternatives. If you are thinking about how to do a better, life cycle cost analysis, and in terms of effective space use, but also energy consumption. So yeah, so this table, I think it sets up nice examples of how those occupant-centric metrics can be used to guide the design processes. Okay, so I'm going to wrap it up, and so obviously there's a lot of journal articles got published, during the last 10 years. And if you're interested, I just listed 4 more relevant ones, and you can take a quick read. But the 3 books listed here, I think these are actually excellent books if you're interested in knowing more about behavior, building design, and then broadly about energy and behavior. In the middle of the book, written by a nice group of people with very different perspectives in architecture, engineering, data science, policy, social science, and we talk broadly beyond buildings sector, transportation, food, so it can be an interesting book to read. And the other 2 books are produced by Annex 66 and Annex 79. And that's the book we are talking about. So these unfortunately, I think only the Annex 79 book is open access. The other 2 books you may need to, to buy. So yeah, I would like to thank Liam and Fan Hang, for leading us to write a book. It's a long journey. And so our work for this is funded by Building Technology Office, United States Department of Energy. So with that, thank you for the opportunity, and I would like to take some questions.
Thank you, Tianzhen. That was great. And I would like to invite everybody who has a question to just put it into the question and answer box, and then I will put the questions to Tianzhen. In the meantime, though, I have a question of my own. I think, how do you envisage managing debates when some of these metrics produce conflicting results? So the case that I'm thinking of is perhaps more in domestic accommodation, where we see that that larger houses, obviously, as you would expect, they use more energy, but the EUIs tend to be lower than smaller houses. But you would anticipate that if you were to look at that energy consumption normalized by the number of occupants, you might see quite a different picture. So one of these is telling you that your big house is performing better, and one of these is telling you that your small house is actually performing better. So how do you manage that conversation, that debate? Is it a matter of choosing one of these and agreeing it in advance? Or can you make some kind of accommodation between both?
Yeah, Pamela, I think that's a great question. I'm thinking that question from the context of building energy codes. And so I'm thinking that California's Energy Code Title 24, right, has been getting more and more stringent for the last 30 years. And so if you look at a per square foot, per square meter basis, it's EUI is right, getting right, down for the last 20, 30 years. But again, the houses size getting bigger. And so the overall total energy consumption is actually not necessarily going down. And so then, the state is trying to get to net zero energy, right, by 2045. But then the question is, well, how do we change the code? So we put a quota, like every household, like 2 or 3 people, you should have a quota of certain kilowatt hours a year. And then beyond that, you may have to do something to compensate, put a PV, some sort of renewable generation, right, in order to compensate that. I think it's a regulation kind of, tough questions that the state has been asking, but setting those kind of occupant-centric KPI sometimes is sensitive, right? Because it touch upon different other social, questions. And so I don't think it's a solution now, but the state definitely is interested in looking at, this question.
Yes, that's really interesting. And so taking that a step further, there's a question from Thomas Crook in the audience. Do you see in the future potentially these metrics being used perhaps either instead of EUI or possibly in Europe instead of energy performance certificate grades?
Yeah, so that's a question I'm not very familiar. For example, Europeans are building performance directives, and but I'm thinking that's always a transition. Maybe during the transition, we definitely can consider multiple performance metrics. The traditional metrics, basically, and there's a reason why it's get used, because the building's total floor area don't change like as often as the number of people, right? So that's why that goes to the denominator, and it's easy, right? You can measure or from the design document, but the other occupant information you would have to do more, frequent measurements. And so, yeah, I think there's pros and cons, but obviously, by using multiple performance metrics that allows you to look at, building performance from different aspects at a different stage of the building, life cycle.
Thank you. And then another question from the audience, from Paul Roosevelt here at UCL, and about how do you see a way that these metrics might need to be adapted to account for hybrid patterns? So traditionally we've thought as sort of domestic and non-domestic activities as really very separate. So domestic activities take place in the home and non-domestic activities take place in the workplace, whether that's an office or some other type of building. But obviously post-pandemic, we see increasingly that people still work from home, and that some of that non-domestic activity has been transferred into the domestic setting. And is there a way of accounting for that within the metrics?
Paul, thanks for joining us. I think that's an excellent question. And yeah, I think indeed, right, with the pandemic, even right, we are now in the post-pandemic, but most people are still, right, have 1 or 2 days or 3 days working from home, right? So, the traditional, right, split, all the boundary between, right, residential and commercial, becomes a blur. And so I think actually that raises a needs. How can we then better evaluate, the building performance? Because now, for example, a home's energy consumption may increase, right? And it's not because, right, compared with before, like some energy waste, it's more, well, now I have to work home 3 days a week. And I have to use, right, equipment, laptop, printers, monitors. And so how we fairly consider that work from home, what is the fair, credit or, allowance that goes to buildings' total energy use to accommodate, right, the values of, of productivity, right, that, from working in home. Yeah, I don't know, and that's Paul. I think that's a question you may be thinking much more ahead of me, like in terms of how to informing the policy in the future. Should we consider, like, right, when we try to set different standards for the residential and commercial buildings?
Yes, I think, Paul, if you have any other thoughts on that, do pop it in the Q&A and we can pick that up and continue the conversation. In the meantime, I have a question thinking about some of the other measures that you were looking at in terms of the things like the interactions between occupants and the building. And just wondering, with heavily serviced buildings, how much that will be influenced by the occupant's understanding of the building and how it works. Certainly my experience of some heavily serviced buildings has been that the occupants have very little understanding of how the building is intended to operate and may have multiple interactions with the building that don't in fact have the effect that they're looking for. You might have big swings in temperatures because of, sort of continually adjusting set points and so on. And how do you accommodate that sort of knowledge and education piece alongside the metrics?
Mm-hmm. Yes. So that's another great question. I'm thinking like a building maybe 30, 50 years ago, they are very simple. Right, so you open a window, then right, you can open the menu and close it. So there's not much need, like a light switch, right, on and off. There's not much need to talk about actual education, But our buildings today are very complicated, right? There's some more IoT devices, more kind of automatic controls, and some of the sensing you don't not necessarily realize, right? The sensors there. And so I think actually that is a need, as we are getting to more, sometimes we use the term smart building, for occupants to understand what you can do and how your behavior or interaction may actually change the building performance. And so I'm thinking about like every car, you have a manual, owner's manual, right? But our buildings are getting complicated. I think we should have some manual, but more important, have some training. If there's a new employee or new worker in the building, I think they need to be, 30-minute briefing, like, what are the smart things and that relates to their potential activities and how they may influence the building performance. I think that is definitely a need.
Thank you. Yes, I think that sounds very interesting. I wonder if everybody has read the manual for their car and whether they would read the manual for their office as well. But I think, in definitely better understanding of complex systems is needed. There's no doubt about that. So another question from the audience, from Marina Topuzzi from the University of Oxford, asking about large-scale deployment and what's the least disruptive occupancy monitoring solution that balances the need for data accuracy against the invasiveness of the technology.
Yes, that's a sensitive topic. I think, especially we're talking about these occupant-centric metrics, we need to understand the occupancy. And sometimes then it comes down to the privacy and some concerns. But I think there are technologies available there that can do this kind of, anonymized, sensing, like using, those kind of Wi-Fi, the existing infrastructure. Those kind of Wi-Fi internet signals. Of course, we have to use it in a very, careful way. But those kind of means or techniques can give us some, estimate, and these are good enough estimate of the occupancy. And yeah, I think people definitely have concerns about those kind of sensing, but they're also realizing. I mean, if you look at the other privacy issues, you Google, right, your name at Google, there's a lot of information out there. So I think all this occupancy sensing actually is not much more than that level of public information. And so I think, yeah, some of the existing infrastructure will give us a good enough, estimates of the occupancy levels that potentially can use to help calculate those, occupant-centric KPI.
And I think there are also, whether you like it or not, there are large data sets that are available commercially that will give you your data about where you've been based on your mobile phone location and how long it's been there. So there are definitely, for example, in the hospitality sector, data sets that you can purchase that will tell you not just how long a mobile phone has been in a particular location. They'll also tell you roughly where that mobile phone came from, which I believe is used to target advertising. So if the mobile phone comes from a more affluent neighbourhood, you might want to promote this type of alcohol, and if it's from a less affluent neighbourhood, there's some other approach you're going to take. But so to a certain extent that data is out there, and you are not able to control that, but it is aggregated data that is available as well. So another question from the chat, and this is about environmental chemical concentrations and whether how that might impact on the building efficiency. So I guess, thinking about, for example, indoor air quality and monitoring that, and whether that might be another metric which might be useful as well.
Yes, I think the IQ, by usually CO2 concentration is used as a proxy, right, to represent a ventilation performance. I mean, there's arguments of that, but definitely, I think that's a key metric to ensure the occupants' health. And I think here in California, actually, it's a very significant effort that goes to look at the IQ in schools. And as you would imagine, some old schools don't have effective ventilation. So the indoor CO2 basically gets to 2,000, 3,000 ppm. And you imagine these are the kids, right, running around, and CO2 at the level, basically they get sleepy. And so how can they learn effectively? It's a big issue. So I think there's a lot of monitoring of hundreds of schools to understand this issue. And that requires, right, school have to do retrofit to ensure, right, it's, effective ventilation. And those are during the normal times, in the state, we sometimes also have the wildfire. And that's another issue during the wildfire, right? How you ensure the healthy indoor environment. You might have to do some filtration, basically more techniques and technology to ensure, right? Those are safe environment during those special, wildfire, days.
Yes, and those, while that might once upon a time have been confined to California, that is an issue that actually certainly across North America has become increasingly problematic, and obviously in other parts of the world as well. I think that's another really important issue. So thank you for another great question. I think that's all we've got time for in terms of questions. I would just like to share my screen again briefly to say a little bit about what is coming up. So as Tianzhen has said, we've actually got a busy couple of weeks. We've got a very busy May. Next week on Monday, we have Liam, who is going to be talking about the introduction to occupant modelling, and just over a week later we will be talking about fit for purpose occupant modelling with Ardeshir Madhavi. And then Farhang, the other co-editor of the book, will be along at the end of May talking about advanced simulation methods for occupant-centric building design. Before in June we have the final two of the webinars. So you will get in the email that you receive after this session, you'll get the sign up links for all of that, or you can see the sign up links on LinkedIn if you're part of the IBIPSA group on LinkedIn. Do please join if you're not already a member. There's a lot of fascinating discussion that goes on there. We won't just be talking about occupant-centric simulation-aided building design in May, though. We are going to be continuing discussions about urban building energy modelling tools as well. Tianzhen was actually one of our speakers in the first series of webinars that I was involved in, when we were talking about some of the theory behind urban building energy modelling. And now we're in the sort of next phase of that, where we're talking about the tools and their applications and some case studies. So on the 24th of May, we'll be talking to Jerome Kempf, who is going to be demonstrating CitySim and some of its applications. So do sign up for that as well. And if you have missed any of the previous sessions and you'd like to find out more, then don't forget that they are all recorded and they are all available on our YouTube channel. So do subscribe to be notified about new videos when they are released, and that's at IBIPSA University on YouTube. There is a lot of content there. This screenshot is from a little while ago. I think we're in more like 60 videos that we have now. So do look at that content. There's a sort of whole curriculum on building performance simulation that you can follow there. Something for everyone. And finally, the work that we do as IBIPSA is made possible by our supporting members. So do please consider joining as a supporting member to help with that work. So the supporting members receive either a print subscription to the Journal of Building Performance Simulation or an online subscription to it, and they have the right to use the IBIPSA supporting member logo. The subscription fees are extremely reasonable, so these have been unchanged since before the pandemic, so that's about 5 years now. Don't tell Drew, he might decide it's time to increase the charges. Sign up quickly before he does. But for $30 if you only want the online subscription for students, and $70 for full members, it's really very, very good value. And you can find out more about that at ibipsa.org/membership. But it just remains for me to say thank you again to Tianzhen. That was a fantastic tour of occupant-centric performance metrics. I hope you enjoyed it as much as I did, and I hope you can join us next week when we're talking to Liam. Thank you, Tianzhen.
Thank you, Pamela, and thanks everybody.
Thank you. Bye, everyone.